So we have discussed already the concept in magnetic effect of current. Now let us see the questions here. So here given that a straight wire of length 0.5 meter carrying a current of 1.2 ampere, right? Magnetic field is given 2 Tesla and actually magnetic field is perpendicular to the length. So everything is given to you, just you have to substitute, you have to use this force I L B sin theta, right? So current is actually given to you 1.2 ampere, length is given 0.5 meter, magnetic field is 2, sin 90 is 1. So you are going to get here 0.5 into 2 gives you 1, so total force is 1.2 Newton. This is directly based on formula F is equal to ILB sin theta, right? So here no problem in this kind of question. Let us go to the next one. Here in this question, before doing this question, you have to know about the, what you say, actually you should know the charge and mass of each subatomic particles. Okay, so that is very important. I'll give you. So let's know this charge, mass. You have what particle like proton, then you have got electron, then you have got alpha particle, and then you have got deuteron. 1 is 2. We can call it deuteron also. So it is relative charge. Actually charge of proton is E, mass is 1. Electron charge is also the same charge, but mass is 1 by 1837. Alpha particle charge is plus 2e, mass is 4. Deuterium charge is plus e, mass is 2. This information is very important, you have to know, and remember this is only applicable when you are finding the ratio, otherwise this things is not will be used for solving the question. Mass 1, if mass of proton is 1, then mass of alpha particle is 4. It is a relative value. Now they are saying that ratio of the radii, and they are saying equal momentum. When they are saying equal momentum, actually you have to take the formula of radius in terms of momentum. Actually you know that R is equal to mv by qb. mv your momentum, you write p by qb, right? So equal momentum, so this radius depends on momentum, right? But equal momentum means it is out, and they are going to a constant magnetic field. This is also out. The radius R1 by R2 is equal to Q2 by Q1. Q2 means second charge particle, and here what is important thing is first one is given hydrogen. Second is given alpha particle. So when you are finding the ratio, first is hydrogen is there, second is your alpha particle is there, right? So alpha particle second one. So here inversely proportional charge of hydrogen, here charge of alpha particle. So charge of alpha particle is 2e and charge of hydrogen is e. So you get the answer as 2:1. Second option you get the answer. Now we have given that a proton and alpha particle both is going into the uniform electric field moving at right angle. So you know that when a particle goes to right angle, it will have a circular path. It will follow a circular path, right? And in that circular path, you know that radius, just now we have done mv by q. Kinetic energy formula you write half mv square. So velocity is q BIR by m. So write half m. So q square b square r square divided by m square. So this m and this m get cancelled. So you get here q square b square r square divided by 2. The kinetic energy depends on the charge of particle, magnetic field, radius and mass. Now in the given situation, what is constant, what is not constant, that we have to see. So proton and alpha particle, okay, definitely they have different mass, they have different charge, okay. But it's saying that moving at right angles to if the radius of circular path are equal, radius is equal, out. Kinetic energy is magnetic field, same magnetic field, that is also out. So actually you know that you can write now this kinetic energy or energy actually is proportional to Q square by M, because 2 is a constant thing for ratio no need. So what you will write here, E1 by E2 is equal to Q1 by Q2 the whole square into M2 by M1. Right, so when you write that, energy of proton first given, okay, so energy of proton first given, so E1 by E2 actually Q1 by Q2, so energy of alpha particle is given is how much? 1, and we don't know the energy of second, E2. Q1 by Q2, so alpha proton particle charge is E and alpha particle charge is 2E into M2 by M1, so mass of alpha particle is 4 and this is 1, right. So actually if you do this, you get 1 by E2 is equal to E will get cancelled here, so you get 1 by 4 into 4 by 1, right. So energy you get same at is 1 mega electron volt. So answer is this. Next, this is a conceptual question. If you understand the concepts like that, you can mark the answer, otherwise it's very complicated question. So here current is going and current will get divided here. So what current will go this side, that depends on resistance. In electricity chapter, if you take the resistance of this is R, right? So this is 1 by 4th part is R, then this part is 3R. And you know how to divide the current. I1 is equal to, here more resistance, less current, okay, and here less resistance, more current, and then you have to find out magnetic field, right? That magnetic field things you have to find out here. One is actually current is going in this anti-clockwise direction and here current is going clockwise direction. So magnetic field due to clockwise direction, you know, into the plane, this is out of the plane, and net magnetic field means you should subtract, because into the plane, out of the plane, they will be actually different will be there. So to find out net magnetic field, you have to subtract both of them. But in this condition, one rule is there. The rule says that it is a symmetrical figure, symmetrical figure we can call a square, rectangle, circle. These are called symmetrical figure, right? Okay, for a symmetrical figure, if the same current is entering and the same current is coming outside, then magnetic field at the center will be equal to 0. Otherwise, you have to find out magnetic field due to this current, magnetic field due to this current. One is into the plane, one is out of the plane, and you have to actually subtract net magnetic field is equal to B1 minus B2 you should do, because they actually one is into the plane, one is out of the plane, right? That becomes little difficult, but that concept you know means directly you can find out magnetic field at the center is equal to 0 for symmetrical figure. Next, here a long wire carries a current is bent into a circular loop. Actually here a wire is only the length of the wire is constant, so whatever wire you are taking, same length will be there. Okay, length is same but number of turns are different, so I will tell you one concept here. If you are actually length of the wire is equal, L1 is equal to L2, so actually you can write L1 as 2 pi R1 into N1, L2 you can write 2 pi R2 into N2, 2 pi you will get cancelled, the number of turns ratio N1 by N2 will be equal to R2 by R. Magnetic field at the center of circular coil is mu naught n I by 2. Right. So here what happens, current will be actually the same. Mu naught is constant, so magnetic field depends on number of turns and radius. B1 by B2 is equal to N1 by N2 into R2 by R. Right, now he is trying to relate this magnetic field with number of turns. What happens, the same wire, not different wire. Same wire means number of turns will change, radius also will change. Many students just will think number of turns increase directly proportional to N. No, N actually decides radius also. More number of turns of the same wire will reduce the radius, right? So in the beginning magnetic field is your B, final magnetic field is B2. Okay, and actually in terms of number of turns, so R2 by R1 again you can write as N1 by N2. So you write N1 square because R2 by R1 can be written as N1 by N2. So N1 square by N2 square. Okay, so here in the beginning number of turns given as 1. This value is given 1. So this is coming as B2 is equal to, here it is 1, this is N. So you get N square into B. Okay, so magnetic field will be N square into. Very important model. Okay, but I'll tell you like the very simple method. You have to find out total magnetic field at the center, right, for this point. So actually classify these things into 3 parts. This is first part, second part, this is third part. So magnetic field at the center is equal to magnetic field due to the first part, magnetic field due to the second part, magnetic field due to the third part. And magnetic field due to the first part is equal to mu naught I by, it is a semi-infinite because one end is closed, one end is infinite, semi-infinite, mu naught I by 4 pi R. The distance from here to here is R. And actually this is what you can find out. This is semi-infinite wire, not a problem. You can actually, you should understand, from one side it is coming from infinity, one side it is blocked, it calls semi-infinite. Magnetic field due to semi-infinite wire is mu naught I by 4 pi R. R is the distance from here to here. Now actually this first wire is in XY plane. First wire is in XY plane. So magnetic field will be perpendicular. So magnetic field will be perpendicular to the plane, means it will not be I cap, it will not be J cap, it will be actually K cap. Magnetic field will be K cap. Now here you know that clockwise direction current is going, means into the plane. Into the plane means minus K cap. Remember, into the plane means minus K cap. It is going inwards. Outward it goes means plus K cap. So magnetic field due to the first part, mu naught I by 4 pi R minus K cap. Magnetic field due to the second part is actually semicircle, and you write mu naught I by 4R. Mu naught I by 4R, and this is semicircle, right? And actually here this is in this YZ plane. So this is J cap and this is K cap, right? So J cap and K cap, it is there, means it is perpendicular, you get I cap. And this is actually minus. The reason is it is again into the plane. Then you write mu naught I by 4 pi R. Okay, again here into the plane only you will get. So this is the XY plane, this wire, again you get minus K cap. Fine, this answer is fine, but total magnetic field you need to add all of them. So according to this, he will, in every option you see mu naught I by 4 pi R is common. So total magnetic field you will actually write P is equal to, you have to take common mu naught I You have to take common is mu naught I by 4 pi r. Okay, and here minus sign is in everywhere, so minus you take common. So when you take common, and this is actually, this 2 will be added, remember that this 2 will be added, same value, so 2 times. So 2 times it is there, and mu naught I by 4 pi r we have taken common, so left out here is 2 k cap. Okay, 2 k cap, and here it will be left out is actually plus, because minus we have taken common, plus pi I cap, right? So the option will be pi I cap plus 2k cap minus outside first option, right? You need to add all the magnetic field, right? Next, two similar coils of radius r are lying concentrically with their plane at right angle to each other. The current flowing in them is I1 and I2I respectively. The resultant magnetic field at the center is, two similar coils are there, radius is r. This is one, this is another one. So actually their planes are mutually perpendicular. Planes are mutually perpendicular. So actually one is like horizontal, one is vertical. So total magnetic field, when you have this kind of situation, total magnetic field, you use B is equal to root of B1 square plus B2 square to B1 B2 cos theta. And their planes are perpendicular, means theta actually is 90 degree. So total magnetic field at the center will be equal to root of B1 square plus B2. And that B1 you get here is mu naught I by 2r, same radius, and the B2 you get is mu naught 2I by 2r. Right. So actually what you can write here is, you have B1 square and B2 square you have to do, right? So actually you will be writing here total magnetic field B is equal to, if you square it, everything you can take common, like mu naught by 2r whole square, in bracket left out is your mu naught I also you can take common. So this is 1 square plus 2 square. So here mu naught I by 2r actually you will write as it is, and 1 square is 1, 2 square is 4, get root 5. Root 5 mu naught I by 2r, the first option. Now you have to find out this one, magnetic field at the center P will be. That center means actually you see current is going according to right hand thumb rule, the magnetic field will be into the plane. This will be out of the plane, because you can apply right hand rule and you can check, right? So this will be into the plane, this will be out of the plane. So total magnetic field at the center is, like let's say this is magnetic field at center is equal to B1 minus B2. B1 minus B2, because this is actually, if this is 1, magnetic field due to first wire is mu naught into current is 5 divided by, for infinite wire you use 2 pi into r, r is the distance, pi by 2, minus for second one mu naught into 2.5 divided by 2 pi into 5 by 2, same thing. Everything as it is, everything you can take common, right? So what is left out here actually is, you can write mu naught divided by 2 pi into 5 by 2, you can take common. Left out is 5 minus 2.5. this 2 will get cancelled, left out with u, and current is actually there, right? Current we didn't write, current already we don't, yeah, current value already be 5 and 2.5. So what you are getting here is mu naught by pi into 2.5 divided by 5, it will get cancelled 2 times. You get mu naught by 2 pi. So this is the answer for this. Now given that a long solenoid of 50 cm length having turns 100 turns carries a current of 12.5 ampere, the magnetic field at the center of the solenoid is. Here magnetic field at the center of solenoid, you will be writing this direct formula mu naught n into I. Small n is number of turns per unit length. Number of turns is 100. Length is given 50 centimeter, that is 50 by 100, right? Because number of turns is given 100 and here 50 is there, that is length. Okay, length is 50 centimeter, you have to write into me. Okay, so you will write finally what you will write here is 2 into 10 to the power 2, because this will get cancelled 2 times, 2 into 10 to the power 2. So magnetic field at the center is mu naught, value you write 4 pi into 10 to the power minus 7. Number of turns per unit length is 2 into 10 to the power 2. Current is 2.5. So this 2.5 and this 4 gives you 10. Okay, 10 and this pi value 2 into pi you can write here 6.28 into 10 to the power minus 7, 10 to the power this minus 5 into 10. Finally you get is 6.28 into 10 to the power minus 4 Tesla. What answer? This problem you need to understand perfectly what actually is asking, because the way diagram is drawn, it's not like clear for you, will not be understanding. You understand this is not the wire, this is not the wire, this is the wire perpendicularly kept. You have to imagine this is like wire, dot is the wire, not this is not the wire, dot is the wire. You can imagine like wire is there in this perpendicular to this dot, you can think. So here he is saying that net force is asking on this wire which is kept at the center. Arrangement of 3 parallel wires, one wire, another wire, another wire, parallel wires. So this dot is representing a wire of length L. Arrangement of 3 parallel wires are given perpendicular to the plane of the paper, carrying the same current along the same direction. Magnitude of force per unit length, actually force per unit length formula is mu naught I1 I2 divided by 2 pi t. Now here actually is asking force per unit length, is asking force per unit length on the middle wire P. So if you take from this side, same force, from this side also same force, because same current is passing, right? So net force actually you will write as F net is equal to root of F1 square plus F2 square. Then here current is same, so you will write here mu naught I square divided by 2 pi d. Yeah, 2 pi t. Infinite wire plus again you will write here mu naught I square divided by 2 pi t. This is force or unit length, you have to do square of it. So same force is there, so you can get resultant force root 2 into F. So you write root 2 into whatever force we have, mu naught I square divided by 2 pi t. To get mu naught I square 2 pi t, so here root 2 will come in the denominator, root 2 and 2 get cancelled, so the answer will come this third option. Okay, this question is circular loop of area 0.01 meter square carrying a current of 10 amperes held perpendicular magnetic field of intensity 0.1 Tesla. Torque, like all formulas will follow from electrostatics, torque is equal to, you write mb sin theta. Okay, so actually area is given to you 0.01, current is given, torque is mb sin theta. For circular loop, actually you have to find out m is equal to n into I into A, right? But here number of turns not given, so directly you write current into area of cross section. So current is actually given as 10 ampere, area of cross section is given 0.01. 0.01 into 10, if you do it, you get 0.11. So this is magnetic moment is 0.1 and magnetic field is given to you again 0.1. Okay, held perpendicular, so directly actually angle, how do you take? This is the most important thing for this magnetic moment. Actually here torque formula will be there, m cross b. So you have to check the direction between magnetic moment and magnetic field. So magnetic moment direction itself is perpendicular to the plane, and magnetic field is also perpendicular, right? So that theta becomes 0 in this condition, because magnetic moment is perpendicular to the plane and magnetic field is again perpendicular to the plane. So both are parallel, theta becomes 0. So I told you that when it is this kind of question, you have to find out, means actually direct angle is not taken, whatever angle taken from that 90 you need to subtract. Perpendicular means it will be parallel means it will be perpendicular, like that you should think. So your angle is 0, so answer will be C. Now you have given that in ammeter 0.2% of main current passes. So actually in an ammeter 0.2% of main current passes through galvanometer. So 0.2% of main current passes through galvanometer, right? From here actually you can find out I by Ig, 100 divided by 0.2. That is I by Ig is actually, if you get 500, and actually that is n, we can write as n is equal to I by Ig, new range by old range. Okay, now here he is giving that we have to find out for shunt resistance. Shunt resistance formula is G divided by n minus 1. G is G only, n is given 500 minus 1. So the shunt resistance is G divided by 499. But he is not asking what is the shunt resistance. He is asking actually what is the resistance of ammeter. Resistance of ammeter means ammeter is a combination of galvanometer plus one resistance is connected in series, that is shunt resistance. Now they are in parallel connection. So that actually effective resistance, otherwise you will find out resistance of ammeter, you can find out as R1 R2 by R1 plus R2. So R1 R2, so galvanometer resistance is G by 499. Then G plus G by 499. Okay, so here if you do it, here you get G square divided by 500G. Finally, the answer is G divided by 500. Thing is that he is asking the resistance of ammeter, right? He is not asking shunt resistance. That is important, because after getting that, answer is also available, so you will actually mark this, but the answer is resistance of ammeter. Ammeter is a combination of galvanometer and shunt resistance in parallel connection, right? And a millivoltmeter of 25 millivolt range is to be converted into ammeter. So actually you have to convert into ammeter, right? And you know that to convert ammeter, what is the shunt resistance formula is S is equal to G divided by N minus 1. But before it is given a millivoltmeter of 25 millivolt range, it's converted into ammeter of 25. So actually that N formula is, we have also this new range by old range also. So you have to, actually new range is given, not a problem, 25 ampere, but old range you don't know. Old range of current you have to know. He has given voltage. So, but you know that current is equal to voltage by resistance if you use here. The voltage is given millivoltmeter 25 millivolts, so 25 into 10 to the power minus 3 divided by resistance of galvanometer is G. So, this is actually current range in old situation. Old range is this, right? This is your old range. And new range already given to you. So first new range is actually given to you. Current new range is actually given is 25 ampere. N value you have to find out. New range by old range. So new range is 25 into 10 to the power minus 3 divided by G will come here. This will get cancelled. N is equal to, you get 1000. Now shunt resistance S is equal to G divided by N minus 1. But actually you can neglect this. The reason is this is so much big value. So you can write G divided by 1000 capital. 1 by 1000 0.001. This is the answer.